And welcome to Purple Mountain Maths. We're doing the 2024 HSC paper for Maths Advanced. This is part 9, question 27 and 28, worth 12 marks. Question 27, part A. Find the derivative of x squared tan x. Okay, so we need to recognise that the structure of this is going to require us to use product rule. So u equals x squared and v equals tan x. U dash is therefore 2x, and v dash, you can refer to the reference sheet if you need to, but tan differentiates to x squared x. Therefore, y dash equals uv dash plus v u dash. So it's x squared x plus tan x times 2x. So I might rewrite that as x squared x plus 2x tan x. And that's done. Part B. Hence, find the indefinite integral of x tan x plus 1 all squared dx. Okay, let's give that a go. The first thing I want to do is expand it out. So it's x tan x, and all of that is squared, plus 2 times the product, which is x tan x, plus 1 dx. All right, so I'm integrating x squared tan squared x plus 2x tan x plus 1 dx. All right, so the fact that they say hence means I know it's going to be useful to use part A above, but part A will help me integrate x squared x plus 2x tan x. But I can create that by remembering my trig identities. So the fact that I know that sine squared x plus cos squared x equals 1 tells me if I divide through by cos squared that tan squared x plus 1 equals x squared x, and therefore I can replace tan squared x with sec squared x minus 1. So let me go ahead and do that. So x squared and then sec squared x minus 1 plus 2x tan x plus 1 dx. So now I have x squared sec squared x. I'm going to write the plus 2x tan x term next. Then I'm going to subtract the x squared at 1 dx. So now those first two terms I know will integrate nicely back to x squared tan x using part A, and I know that the rest of it will turn into a third x cubed plus x plus c, and I'm done. Question 28. Anna is sitting in a carriage of a Ferris wheel which is revolving. The height, a as a function of t in metres above the ground, is given by this function, where t is the time in seconds after Anna's carriage first reaches the bottom of its revolution. C and k are constants. The top of each carriage reaches a greatest height of 39 metres and a smallest height of 3. Find c and k. Okay, pause here to do it yourself. Okay, so let's interpret the 39 and 3. So this is ground level. What they're saying is that the bottom of it is at 3 and the top of it is at 39. So all of that is 39 less 3, which is 36. And so the halfway point is 18. So this much is 18. And this much is 18. 3 plus 18 is 21. Okay, so this helps me see that in this structure, the cos curve is being scaled by that k, which is 18. And the c is how much the whole curve has been shifted up above ground level, and I can see that that's 21. So C is 18 plus 3, which is 21, and that's part A. Okay, part B says, how many seconds does it take for one complete revolution of the Ferris wheel? Well, I know in all of these questions, when I'm dealing with a sine wave or a cos wave, the period equals 2 pi on A, where A is the coefficient of the x, or in this case t, in the cos curve. So it's 2 pi divided by pi on 24, so I get 48 seconds. Okay, question 28, part C. Billy is in another carriage. The height b of t in metres above the ground of the top of her carriage is given by that function, where c and k are as before. During each revolution, there are 2 occasions when Anna's and Billy's carriages are at the same heights. At what 2 heights does this occur? Give your answer correct to 2 decimal places. All right, so let's make sure we understand the structure of this question. We know that there's an A of t, which is all about Anna, and that is c minus k cos pi t on 24. So that's describing Anna, and this is describing Billy. So we can see in both cases, we've already worked out that K is 18 and C is 21, and we can see that Billy's curve is time shifted by 6 seconds. All right, so now that we know the structure of that, equal heights implies that those 2 functions are equal. So we're going to set A of t equal to B of t. So c minus k cos pi t on 24 equals c minus k cos of pi on 24 t minus 6. Okay, so subtract c from both sides, and then divide both sides by minus k. We're really talking about the scenario when cos of pi t on 24 equals cos of pi on 24 t minus 6. Okay, so for that to be the case, maybe it's because pi on t minus 24 equals pi on 24 t minus 6, but actually we know that that's not possible because Billy and Anna are in separate carriage, so that's not the answer. It could be that pi t on 24 equals 2 pi minus pi on 24 t minus 6. Okay, so in other words, t equals 48 minus t minus 6. I get 2t equals 54. So it's possible that t equals 27. That's one possibility. Or it could be that 2 pi plus pi t on 24 equals 2 pi minus pi on 24 t minus 6. So if I play with that a little bit, I get t equals minus t plus 6, 2t equals 6. I get t equals 3. All right, so now I've found the times at which that occurs. Okay, so having found the time at which these occur, we're actually being asked to find the height. So let's go ahead and do that. It doesn't matter which of the formulas we sub into. I'm going to sub into A because I think it looks a little bit easier. Let me do A of 3 first of all. A of 3 equals 21 minus 18 cos pi 3 on 24. I put all of that in the calculator. I get 4.37. And now I'm going to put in t equals 27. 21 minus 18 cos pi 27 on 24. I get 37.63 metres. So those 2 heights are my 2 answers. That's the end of part 9. Thanks for listening to Purple Mountain Maths.